In Lesson 6.6, the example, a few more pennies for your thoughts, we'll be looking at sampling from a non-normal population. Mr. Ramirez's class did the penny for your thoughts activity from the beginning of this chapter. The histogram shows the distribution of ages for the 2,341 pennies in their collection. So you can see that we have the year recorded. We go down as low as into the 1950s and as high as into present day. Both part A and B of this question are asking us to describe the shape of the sampling distribution of X bar, or the sample mean, for different sizes of samples, of simple random samples that will be taken. In order to determine the shape of the sampling distribution, we have to analyze the shape from the population. We can see that this is skewed to the left, or we can use the normal or large sample condition. So if the sampling that we're doing is coming from a population that's approximately normal, no matter what the sample size is, our sampling distribution will be approximately normal. Or if we have a non-normal distribution, like in our case here, the sample size needs to be large enough. And what we define as large enough is the sampling distribution of X bar will be approximately normal, in most cases if the sample is bigger than 30. So now that we have this background, we can answer parts A and B. A says describe the shape for the sampling distribution if we're taking simple random samples of size 2. Now size 2 coming from a non-normal distribution is too small. It's less than 30, so the sampling distribution of X bar will be skewed to the left, but not quite as strongly skewed as the population. In part B, we're taking simple random samples of size 50 from the population of pennies, and in this case, even though we're coming from still a skewed population, that sample size is bigger than 30, our large enough sample size condition, so the sampling distribution of X bar will be approximately normal in this case. If you'd like more practice with analyzing the shape of a sampling distribution of X bar, you can try exercise 1 at the end of this section.